Hey everyone, and welcome to This Explainer. I am so pumped you're tuning in today because we're diving straight into a topic that's been plastered all over the headlines lately. You know the ones, the articles claiming artificial intelligence is literally draining our reservoirs and drinking the world dry. Well, today, we're going to unpack the real story behind all that hype. We'll look at the hard data, separate fact from fiction, and figure out what the tech industry is actually doing about our natural resources.
So, we've got to start right here with the elephant in the room. Is AI drinking the world dry? Now, look, we all know fear sells, right? Headlines absolutely love a good villain. But on the flip side, we seriously can't ignore the very real, impending global freshwater crisis. Experts are predicting this could hit us as early as 2040, which is honestly right around the corner. So the totally natural question to ask is, what is AI's supposed role in all of this? Is this massive new tech boom going to be the thing that pushes us right over the edge?
Okay, let's just rip the Band-Aid off. The short answer? No. Are AI data centers using fresh water? Yes, absolutely. But claiming they're single-handedly drinking the planet dry is a massive, massive overstatement. Honestly, pointing the finger entirely at data centers kind of distracts us from the actual root causes of our global water shortages. So let's step away from the sensationalism for a sec and see what the empirical data actually says about global water use.
Section 1. The real water consumers. This brilliantly illustrates the reality of the situation. Take a look at that massive green wedge on the right. Agriculture is the absolute largest water consumer on the globe, dominating at 68% of all usage. And here's the kicker. A huge chunk of this isn't even growing veggies for us to eat. It's growing feed for the dairy and meat industries, which consumes literal trillions of gallons of fresh water. Add in faulty, leaky infrastructure, and man, it takes a massive toll. When you look at the whole pie, the slice taken up by tech and industry, it's just a tiny fraction of the whole shebang.
To really put this into perspective, let's look at a direct comparison. If you take just one specific crop, U.S. corn, and compare it to the entire tech sector, the numbers are just staggering. U.S. corn crops use over 70 times more water annually than all of the world's AI servers combined. 70 times! When we're talking about global water consumption, we really have to keep our sense of scale accurate.
And hey, even if we zoom in just on the tech and entertainment sectors, AI still isn't the biggest culprit. Think about everyday streaming platforms, the ones we all use to binge-watch shows every single night. They use about 40 times more total energy than the equivalent usage of AI prompts. Because generating electricity relies on power plants that use insane quantities of water for cooling and steam, those streaming platforms create an indirect water footprint that easily dwarfs the water needed to cool an AI data center. But acknowledging that AI isn't the biggest problem doesn't mean the tech industry gets a free pass.
Section 2. AI solutions running today.
I want to shift our focus to the proactive steps the industry is actively taking right now to mitigate its environmental impact. What's super fascinating here is that AI is actually being used to solve its own infrastructure problems. Major players, Google, Microsoft, AWS, they've fully implemented AI-optimized dynamic cooling. They're using machine learning to continuously monitor and tweak cooling systems in real time, making them incredibly efficient. And on top of that, utility companies are actively using AI models for predictive grid management. They forecast wind and solar generation so clean energy isn't wasted, keeping these data centers perfectly synced up with green power availability.
Now, it is so cool to see how the hardware itself is evolving. We've totally moved past simple air conditioning. Enter direct-to-chip liquid cooling. Modern AI microchips run so incredibly hot that traditional air cooling literally cannot keep up. I mean, it's just physics at this point. So this closed-loop system runs liquids directly over the chips, absorbing the heat without evaporating any water at all. It's gone from a fancy upgrade to an absolute necessity, and it now accounts for over 38% of new high-density installations. But look, the tech sector moves fast. Let's look at the late-stage projects arriving in the next 3 to 5 years.
Section 3. Innovations arriving soon.
One of the most promising near-term innovations, and this is coming well before that predicted 2040 crisis, is immersion cooling. Imagine taking an entire server rack and just dunking it straight into a giant vat of liquid. That's literally exactly what this is. But it uses a specialized, non-conductive dielectric fluid. It absorbs heat incredibly efficiently, again, with zero water evaporation. This is a highly proven technology. Actually, right now, the industry is doing the heavy lifting of retrofitting older data centers just so their floors can support the massive weight of these liquid vats.
Alongside immersion cooling, we're seeing some brilliant logistical shifts.
Major cloud providers are utilizing workload shifting, or what they like to call chasing the sun. They use AI to automatically bounce heavy, non-urgent AI training tasks to data centers in regions where renewable energy or even just cool ambient air is peaking at that exact moment. Plus, major tech companies have pledged to become water positive by 2030. To hit that, their standard architectural blueprint for new facilities relies on alternative water sources like treated industrial wastewater or municipal gray water instead of tapping into local drinking supplies. So we're looking at a timeline roughly a decade away, pushing towards a completely new framework for how data centers operate on a fundamental level.
Section 4. The Circular AI Future. Let's walk through this timeline to see how it builds. Today, we've got dynamic cooling and direct-to-chip systems. In 3 to 5 years, we're going to see wide-scale alternative water sourcing and immersion cooling. And then, post-2030, we enter the era of microgrids and circular AI. This essentially lays out the tech industry's rapid scaling roadmap, structured as a direct race against those earliest estimates of a 2040 freshwater crisis.
And the post-2030 concepts, they are absolutely mind-blowing. Tech companies are already signing deals to buy power from small modular nuclear reactors, or SMRs, and advanced geothermal plants to create dedicated AI-managed microgrids. This takes them entirely off the public grid. Even more fascinating, though, is the research into capturing the massive waste heat generated by servers and using it to thermally desalinate ocean water or purify wastewater. Imagine a data center that doesn't just use water neutrally, but actually acts as a water purification manufacturing plant. How crazy is that?
So the crucial point here is this entirely new philosophy called circular AI. The ultimate goal is to completely abandon the old linear take, make, waste model. By applying circular economy principles, reduce, reuse, recycle, and regenerate to the entire life cycle of artificial intelligence, the hardware and the daily operations become a self-sustaining closed loop. AI won't just be mitigating its impact, it'll actively be regenerating resources. Which leaves us with a totally different perspective than where we started, right? And it brings me to a final, pretty provocative question for you to ponder. Considering everything we've just learned, is it actually irresponsible not to use AI to solve the upcoming 2040 water crisis? Yes, AI requires some fresh water to run today, but as you've seen, it's a tiny percentage of overall global usage. Meanwhile, the massive problem-solving potential of AI is actively optimizing our grids, designing new cooling technologies, and planning closed-loop systems. This kind of intelligence might literally be the exact tool we need to ensure our future. Thank you so much for joining me on this explainer. I really hope this helped clear the waters for you. Keep learning, keep questioning, and I'll catch you next time.